We have discussed the convolution implementation of sliding windows is an computationally efficient technique rather than giving the captured image of the each window independently to the network. So, but a problem we have observed, we are not getting an accurate bounding boxes. See, if we are taking this window is moving throughout the image, but this is the only image which captured the car well, and this is also not capturing the car in entire way. This is the bounding box we are predicting, this black color bounding box, but this is the bounding box we have observed here. Even in this black color bounding box, you observe the width and height are not same, but here we are considering the square bounding boxes. A window we have considered a square window, like that you can think. Now, YOLO algorithm, you only look once. This algorithm gives the problem for the bounding boxes when you are trying to implement the sliding windows through the convolution manner. YOLO means you only look once. This paper was published in 2015. You can go to this paper if you want to read. The paper title is You Only Look Once, Unified Real-Time Object Detection. This works well even for the real-time objects also. We have considered an image 100 by 100 image. In this image, you observe there are two cars. The two bounding boxes we are expecting here, the two bounding boxes are given like this. For suppose, for the convenience, we are taking a 3 by 3 grid. In real time, we have to consider 19 by 19 or more than that grid size. But for the convenience, we are mentioning the grid is 3 by 3. Now this time, we are taking the image in the grid. Example, this is the first image, this is the second image, this is the third image, like that. Example, this is the fourth image, this is the fifth image. Now, we are labeling, for labeling the output, if that is the input to label the output, we are considering the same 8 elements we have taken previously for the Y, where PC is telling whether a pedestrian or car or motorcycle. These three classes, out of these three classes, any class is present, then PC value is 1. If any class is not present, then PC value is 0. Bx, By are indicate, we have already discussed, Bx, By are indicating the center of that object, center of that bounding box, we can tell. And Bh and Bw are width and height of that bounding box with respect to the image we have discussed. C1 and C2 and C3 are representing those particular classes. If they are present, then those particular values will become 1. Now, if the PC is 0, then all the remaining values are don't care. For suppose, we have considered these 9 boxes because this is the 3 by 3 grid. Here there is no car, 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 here there is no car. But in this, there are two fractions, so small portions of the cars are available. But if we take, there are 2 cars available in this square, then in this grid, then the problem is here also we are detecting car, here also we are detecting car, and it will show us there are 4 cars in this image. In order to avoid that, we are telling to take only the centroid of that image. If this is the centroid of that center of that image, wherever the center is present, that box only you consider the car is present. So even though small fractions are present in this grid, it will be considered as there are no cars in this grid. And here the center is present, so there is 1 car. Here the center is present, there is 1 car. And the output labeling of Y is given like this: 1 1 1 1, because this is the Y for the left car and this is the Y for the right car. We already mentioned Bx, By, Bh, Bw. and 0, 0, because first class and third class are absent in this image, only car is present. So that's why class 2 we are mentioning as 1. Now the total output size is, if we are giving this image as an input, we are getting the output 3 by 3 by 8. Why 3 by 3 by 8? Because the grid size we have considered a small grid, it is 3 by 3. Example you consider. And why 8? Because we have considered 9 grids. There are 9 grids. We have considered 3 by 3. So output is 3 by 3 by 8. Why 8? In the Y we have 8 values. So this is the input image 100 by 100, and we are expecting the output 3 by 3 by 8 because we have considered 3 by 3 by grid. The image with the 3 channels we have given to the convolutional neural network. After max pooling and all layers in the final output, we are expecting the size should be 3 by 3 by 8. If we are taking 19 by 19 grid, then it will be 19 by 19 by 8. Now the question is, what are these values bx, by, bh and bw? How we represent these values? We are taking an example where the car is present. This box, we are taking the coordinates 0, 0 here and 1, 1 here. So the center of that box, center of that object, the coordinates we are getting 0.4 and 0.3. So this is 0.4 towards the x and 0.3 towards y. That's why the coordinates of the center are given here. And BH and BW, the BH, as we already mentioned, they are the height and width of that particular bounding box with respect to the entire grid. Example, this bounding box, this height and width may be even more than the grid also. Example, sometimes the car may come even in these 4 grids. At that time, the width and height of the car is definitely, the width and height of the car, definitely they are more than 1. So bx and by, definitely these values are less than 1 because that is the center and we are taking with respect to 0 and 0, 0 and 1, 1. But bh and bw values, they can be greater than 1. There are methods we take in order to make the values of even BH and BW less than 1. But even if we take BH and BW greater than 1 also, there will not be any problem. This is how we will calculate the values of BX, BY and BH and BW. In real time, we will consider, as we mentioned, 19 by 19. So there is no chance for the multiple objects present in the same grid because the grid size is very small. The center of a object or center of the car can present only in one grid. In this way, we can accurately allocate a particular bounding box to one grid only. So you are only looking once. So that particular car is calculated only once through one grid only. This is how we can accurately build the bounding boxes.